Hello friends, welcome to this video on addressing modes of 8051. So in this video, we will learn what do you mean by addressing modes and different types of addressing modes, in 8051. So every instruction is divided into two parts, opcode and operand. So opcode is basically an instruction which performs some operation on a data, and operands is the actual data which is stored in a register or in a memory location on which instructions are performed. So opcode tells the microcontroller what to perform, and operands are nothing but the on what to perform. So operands are nothing but the data. So in operand there could be a source operand or destination operand. For example, here add a comma b. So add is a opcode which tells microcontroller to perform add operation on the operands. So operands are the a and b. A and b are the registers. So in those registers a data is stored. So add is opcode, a and b are the operands. Addressing mode is a way to address an operand. It basically tells the way in which operands are specified in the instructions. In operands are nothing but the data. So on the data, opcode is performing some operations, and those operands could be a register or any memory location or any numerical data or immediate data. Addressing modes are nothing but how the operands are specified in the instruction. Those operands are basically specifying the location of the data. So accordingly, how operands are specified in the instruction, there are types of addressing modes in 8051. In 8051, there are 5 addressing modes. Those addressing modes are immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, index addressing mode. So we will see those addressing modes one by one. So first is immediate addressing mode. In immediate addressing mode, data itself is a part of the instruction. In instruction, data is directly present. Why it's called as immediate? Because it transfers an 8-bit data immediately to the accumulator or any register, and that's why it is called as the immediate addressing mode. For an example, move a comma hash 07h. So there is a convention in 8051 is that if you are specifying immediate data in the instruction, you have to add pound or hash character. So that pound or hash character in an operand indicates that it is the data, not the address of SFR or any memory location. So hash 07h is the data which is loaded into accumulator. So this move instruction is loading this 07h into accumulator. More examples are move b comma hash 64h. So 64h 8-bit immediate data is loaded into b register. In next instruction, move r5 comma hash 39h. So in this instruction, 39h is loaded into R5 register. So these are the 8-bit data. Similarly, using immediate addressing mode, you can load 16-bit data into a register. So we know DPTR is a 16-bit register in which this 16-bit data 8234 is loaded using move instruction. So since this is the immediate data, hash character is there, and there is another convention is that if your immediate data or the memory location, address of memory location is starting with character, it should be preceded by 0, and that's why there is a 0 before A, and a hash sign indicates that it's a immediate data. So now those immediate data are acting as a source which will be loaded into destination register. So one thing we have to keep remember that those immediate data cannot be a destination. You cannot load another data into that immediate data, because immediate data itself a data which is to be loaded in some other registers. So next addressing mode is the register addressing mode. So in the register addressing mode, source or the destination data is present in a register R0 to R7 or in accumulator. In 8051, at a time only one bank is active, and in that bank there are 8 registers, namely R0 to R7. So to select any one of available banks, we require to select the appropriate bank using help of PSW register. So in PSW register there are 2 bits using which you can select or you can activate any one bank out of 4. So in a register addressing mode, both source and destination are the registers. For an example, move A, R0. So here the 8-bit data of R0 will be copied into accumulator. So before the execution, A is having 00, R0 is having 34, and after execution the 34 of R0 will be copied into accumulator. So now A and R0 both are having same data. More examples like move R5, A. So here the content of accumulator is copied into R5 register, and in next example the one instruction is written which is move R3, R1. There is no as such instruction in 8051, like you cannot move data from one register to another register. So A must be involved as a source register or destination register. You cannot move data from one register to another register like here in move R3, R1. Direct addressing mode. In direct addressing mode, one of the operand of 8051 instruction is the memory location, and for that memory location address is directly provided in the instruction, or address is directly specified in the instruction. So direct address is a part of the instruction. In 8051 there is 128 byte of internal RAM and SFR which can be addressed. So in direct addressing mode, data movement is between a register to memory location or vice versa from memory location to register. So as it is a direct addressing mode, address is a part of the instruction which could be a source or a destination. First we look at the syntax like move A, add. So here direct address is provided in the instruction and from which data will be copied into accumulator. Next instruction is move address, A. The content of accumulator would be copied into that memory location. Third is move register, address. The content of memory location whose address is directly specified in the instruction would be copied into specified register, and vice versa is happen in the next instruction which is move address, R. Next instruction is move address, #n. #n is the immediate data, and that immediate data will be loaded into a memory location of this address. And the last instruction is move address 1, address 2. So here you can move the data from one memory location to another memory location. So address 1 is the destination, address 2 is the source. So data from address 2 will be copied into memory location of address 1. If we look at the examples like move a comma 80. So 80 is the memory location. So from 80, 8-bit data would be copied into accumulator. If we look at the example before execution, A is having 00 and memory location 80 is having 23. After execution of this instruction, the content of the memory location would be copied into accumulator. So now accumulator and the memory location is having same data. Few more examples are move 3ah comma hash 3ah. Though 3a is same, the first is the address and second is the 8-bit immediate data. So hash symbol, hash character is used to identify which is the immediate data. So hash 3a is the 8-bit immediate data which is loaded into a memory location whose address is 3a. In next instruction, which is move R3, 12. So 12 is the memory location from which 8-bit data is copied into register R3 of active bank. We know at a time only one bank is active. Next instruction is move 0AH, 77H. So here two memory locations are directly specified in the instruction. 0A is the destination memory location, 77H is the source memory location. So from 77H memory location, 8-bit data is copied into a memory location 0AH. Next addressing mode is register indirect addressing mode. So in this addressing mode, the address of data is stored in another register. In previous addressing mode, direct addressing mode, memory address is directly specified, but in a register indirect addressing mode, that memory address is not directly specified. That memory address is stored in the register. So there are two pointer registers are used, which are R0 and R1. So only those two registers R0 and R1 are allowed in the indirect addressing mode. So to identify these two registers acting as a pointer register, direct symbol is used. So that direct symbol is placed before R0 and R1, which indicates that this is the indirect addressing mode. If you look at the syntax, move @rp, rp stands for pointer register. So move @rp comma hash n is the 8-bit immediate data. So that 8-bit immediate data is copied into a memory location whose address is given by the register pointer, a pointer register. Next address is move @rp comma address. So content of this memory location is copied into another memory location whose address is given by the pointer register. In this instruction, move @rp comma a, the 8-bit content of accumulator is copied into a memory location whose memory location is given by the pointer register. Move a comma @rp. So the content of memory location whose address is provided by rp register is copied into accumulator. And the last instruction, move address comma rp, in similar way, the content of memory location whose address in rp is copied into this memory location. So examples are here, move a comma @r0. So 8-bit content of the memory location given by R0 is copied into accumulator. If we look at the examples, before execution, I have 00 in accumulator, 80 in R0, This 80 is the memory location, which is having 23. So after execution, so R0 is acting as a pointer register, and in this R0 there is a 80. So 80 will be a memory location, and at that memory location 23 is stored. So that data would be copied into accumulator. So the memory location is indirectly provided by the pointer register. Few more examples are move @r1, comma hash 3ah. So hash 3ah is the immediate data which is copied into a memory location given by r1 register. Next instruction is move @r0, comma 18h. 18h is the address. So content of this address is copied into a memory location given by R0, and the last instruction is move 0AH, comma @R1. The content of memory location given by R1 register is copied into memory location 0AH. So this address is nothing but the address of the RAM 128 byte RAM or SFR address. So in R1 and R0 register, you can store the memory address of 128 byte RAM or SFR address. Next addressing mode is the index addressing mode, and this index addressing mode is used to accessing data elements of a lookup table. So lookup table are the entries located in the program ROM space of 8051 in ROM, which could be external or internal. So in index addressing mode, the effective address or final address from where the data is to be fetched is calculated by summation of base register, which is PC or a DPTR, and content of offset register, which is A. So final address is nothing but the content of base register and the offset register. And normally index addressing mode is used in MOVC and jump instruction. So in MOVC instruction, C refers to the code byte when you are accessing, when you are fetching data from external memory. If you look at the syntax here, MOVC A, comma @ A plus DPTR. So @A plus DPTR is nothing but the address which is formed by adding content of accumulator and DPTR. Content of accumulator is the 8-bit and content of DPTR is a 16-bit. So by adding these two content, we get one address, and from that 16-bit address, data is copied into accumulator. Next instruction is MOVC A, comma @A plus PC. So PC is again 16-bit register, A is a 8-bit register. The content of both registers are added together to obtain final 16-bit address, and from that 16-bit address, data is copied into accumulator. If you look at the example, move A, comma @A plus PC. So 8-bit content of memory location formed by adding 8-bit content of accumulator and a 16-bit content of program counter is copied into accumulator. So before execution, A is having 30 and program counter is having 1150. So when A and PC are added together, we get 1180. This is the final memory location, and let's assume at that location 23 data is stored. So that 23 8-bit data is copied into accumulator after execution. So more examples could be move A, comma @A plus DPTR. So PC is used to fetch the content from the external ROM, whereas DPTR is used for fetching the content of external RAM. So for external as well as internal rom pc is used. So mostly instruction is used with internal and external rom, which can address 4K of internal or 64K of external code. So this is all about the addressing mode of 8051. If you like the video, do subscribe it, hit the bell button, comments and share.